Today, we will learn more about NVIDIA NIM. What is it, for whom it is, and how does it look in practice? What's NVIDIA NIM? Well, it's a new offering by NVIDIA that enables any data scientist, software engineer who wants to start doing generative AI to build applications in a very simple manner. And you can see it already here. So I am at the build.nvidia.com portal that provides a set of models, generative AI models, for different purposes that we can start using immediately. So for example, I have here chat models from Mistral, from Google. I have also text-to-image models, such as this one from Getty Images. I can also generate 3D images, but there is much more than that. So for example, if I go to vision, I can see that there are multiple vision models that enable me, for example, to convert, or not convert, but to take an image and generate a description from this image. Or, for example, also, I have models that enable me to, such as in visual design, to create images that are 2D, 3D, or even videos that I can pass a image and generate a short video clip. All that sounds super exciting, but you might be saying, hey, OpenAI already offers something like this somehow. I have already there GPT models, I have already there DALL-E models, I have also vector embedding models, because of course here in NVIDIA NIM we also have vector embeddings. So if I go here to retrieval, I can see that there is at least 4 available at the moment, plus also one re-ranking model, such that I can build very complex RAG systems. So we can see that we see here offerings that are already available with OpenAI. But why should I be using instead NVIDIA NIM? Well, one benefit of NVIDIA NIM is this portability, where I can run these models in the cloud. So for example, let's go to this one that is reasoning, the Llama 70B, and I can here pretty much like test it. So hello, my name is Rod. And get here a response that is running in the cloud, not different at all from what we get from OpenAI. But also, if I can do not here, but here. But also I can download the container. I can run this locally. I have the possibility to pretty much run this Llama 3 8 billion model, which is a smaller model compared to the 70 billion one. I can run this locally. Also, NIM offers the possibility to run a IDE, a cloud IDE. That's pretty much like Visual Studio Code. And so if I go here, you can see that they have set up a interface how I can run my generative AI models in their cloud IDE that is connected also to their cloud environment. So for example, here I have, if you can see at the bottom, I have this very simple command line that will run the Llama 3 8B model. So this one that we're discussing here, this one here, we will be running here. So let's start there. Let's start just by looking at how we can interact with these NIM models. Yeah, so here, for example, I can just call it, run it, and then it's already executing. Yeah, so, and now it's executing. Well, in theory, I can do requests, start sending prompts here under the port 8000. And so this is one way how I could do it. I could, of course, do it completely locally in my own computer. I could download this. This is in the end a Docker container. So I could download the Docker container and, well, download the image, execute the Docker container, and be able to do this also on my local machine. So here we see that what started as OpenAI similar, now it looks closer to something such as Ollama. Because in Ollama, I can download the specific optimized models from Llama. They have the Llama models, the Mistral models, etc. And I can run them on my own machine without really knowing anything about infrastructure and how to build the way how to run these models. Super exciting. But it doesn't end like that. It has so much more. I can, for example, use this to run on the cloud. And let's start there. Let's start in our cloud model. Here, this is already prepared. Let's start in, so it's loading. Let's start with how we will run on a Google Colab node. We see how with NIM, we can run this on the NVIDIA cloud environment. We have access also to this cloud IDE, but also I can just download the Docker image, execute it locally as a Docker container, and pretty much use it as an alternative to Llama. But how does it work? For example, just using this in a Google Colab notebook. Pretty much what any data scientist, anyone who works with Python these days operates. Well, I have created this tutorial, and this is available online. Anyone can execute it, but let's go through it. Yeah, so I have my API key. In order to get your API key, the only thing that you need to do is when you go, for example, here in this portal, you click here on Get API Key, but you must be sure, you must need to have credits. So in my case, I have here credits that NVIDIA kindly provided to me to do these experiments. So I can get the API key. If I click here, I will generate an API key. What happened to me earlier is that I tried to generate this API key and I could never get that. I was clicking all the time, generate key, generate key, generate key. Nothing would happen. And this was for the simple reason that I had not set up the right group in the settings. So in this page, I did not have the right user group. I had something else, not NVIDIA Launchpad or something different. And as a result, when I will go to this section, I will have 0 credits. And without credits, I couldn't get an API key. Took me some time to understand, but something that you should be aware of in case that you want your API key. So once you get your API key, you can just paste it. And one of the things that the NVIDIA NIM offers is that they say that it is OpenAI compatible with the library of OpenAI. Let's start by installing it and explaining what they mean. It means pretty much that you can run this Python client, and instead of calling OpenAI models, you can call the NIM models in the cloud or the ones that you have hosted. Yeah, so for example, if I go back to our cloud API that we have here, in theory, we have here an IP that we could be querying in order to generate our prompts and our outputs. One thing, however, is that this is not consistent in terms of not all models that are available by NVIDIA. So let us go here back. Not all models are here listed. So, for example, they have here speech models. They have here these retrieval ones that we discussed to generate embeddings and also to do the ranking and so on. Not all of these use the OpenAI API. Pretty much the only ones that are using the OpenAI API are actually those that are like here for chat. And that's basically it. Some for embedding generation in retrieval, they will use it, but not all of them. And this is like the other thing. It is that the payload for the API call is different based on the model that I use. So let us look at this. The Snowflake model, for example. The Snowflake model, if I go here to Python, I can see the type of parameters and how to call it. I have to use the base URL and the parameters I will be using. But if I take, for example, let's go back, this NV embed one, you see that the base URL is different. You see that also here, some of the parameters might be different. And if I go here, for example, in BGEM3, you also see that here there's also change. So it's also something to pay attention to, is that compared, for example, to actually working with OpenAI and its models, given that NIM takes open source models from the community, optimizes them, and packages nicely in this platform, the endpoints, the parameters, and so on, they are not consistent to the experience that we'll get, for example, just in OpenAI. So although it will be said this has OpenAI compatibility, this is partially true. But let's go back to our notebook. We have installed this. We'll need also Pillow to generate images. And the first thing that we'll do, it will be a chat completion. I have implemented quite some code here. I will not go through all of these details. You can go through the notebook and then look at them in detail. But pretty much if we look at what we're doing, just as a quick glance, is that on one side, we are implementing all the 4 embedding models that I have available. And we're also having a chat interface such that we can use the Llama model that we have. So here we are also here defining the embedding models. And here is the Llama 3 8 billion model. Yes, and as a result, with the same implementation, I will be able to generate embeddings as well as chat with my model here within Google Colab. Yes, so let us start by executing it, and we will see what I mean by that. So let's just execute it, and let's start with the for this implementation, we can see that this appears. So this chat interface, very basic. I click here in Start, and then I can say, for example, what is the capital of France? Just to have like some question. Yeah? And I can click Send. And the model replies. I can also continue the conversation. Tell me more about Paris. And we see that we can have really this ChatGPT sort of like interface within Google Colab. But so far, nothing here out of the ordinary. We already know how to do this with GPT-3 or with any other model that are these days available in the cloud. But in this implementation, and also what NIM offers is all these different vector embedding models. So meaning, if you want to have an application that can work with your data that is grounded in your information, you'll be needing a way to convert your information into a vectorial representation with the so-called vector embeddings. And for vector embedding models, depending on the model that we're choosing, is the quality of the vector that we'll be getting. How good is this vector to represent our original data or text? And it's very simple. So here, similarly, I just paste what is the capital of France, and it generates here the embedding. We see the embedding is just a list, a Python list with a set of numbers that for us humans, they do not make too much sense or do not make sense at all. But any clustering algorithm, as well as just simple distances and metrics, for example, cost and similarity and so on, will allow us to compare how close or distant are two different concepts from each other. Meaning, for example, this definition of what is the capital of France, represented as this. When I say, for example, let us put here, France is a country in Europe, the embeddings, these two embeddings will be relatively close from each other because in both cases, I am mentioning France. And I was mentioning that depending on the model that we're using, we'll get different type of embeddings. And we can see it here, for example, let's stop this and let's run now this one here. If I as well So start with what is the capital of France. We'll see that the embeddings that I have here and the result I have here is different. Okay? So here, one benefit that a NIM offers us is that we can really choose which model, which vector embedding model makes the most sense for our problem at hand. Because, for example, with something such as OpenAI, there is only the embeddings API. There is basically one model that we can query in order to generate our vector representation. And this might be excellent. This might be perfect for our use case. But with the one that here in NIM is offering us, we get, at least right now, 4 different endpoints. And NIM is extremely new. They just released it last month in May. And what they're doing is they're integrating all the time new models and run the ecosystem. Not only they're just taking here models that are available open source, but they're making sure that they are highly optimized for this platform, for the NIM platform, meaning this will give better results than if you were to use it just on your own, download from the internet. And the same thing happens here now in this other one that we have here with the Snowflake. I just execute here, and if I just ask what is capital of France, then I should have also an embedding generated that, as we're seeing, is also different from the ones that we have so far. Same here for the BG M3 model. We execute it, and we have it here. And this functionality is also something that belongs to the RAG applications. RAG applications, let's say, this is like the bread and butter of generative AI, right? So many people have used it, many people know it, and so on. This is, let's say, no like breaking ground or something. Anyone working with generative AI should have heard of it, should have already used it at some point. So why should be another reason for you to start using NVIDIA NIM or testing it? Well, it offers much more than just chat and embedding models. We mentioned also the topic of ranker models, meaning when you retrieve information from a vector database, you might want to assess which of the results of the documents that you got are the most relevant, and that you can score it and get the top results first, the ones that are the most relevant to your query, to your prompt, at the top, and the ones that are less relevant at the bottom. And here NIM does exactly that. NIM also offers a re-ranking model. At the moment, there's only one, but I imagine there will be adding more in the future. And here we have, as an example, 3 different texts related to the NVIDIA hardware, and then just a question of what is the GPU memory bandwidth of H100 SXM. So it's a very specific question that most likely a regular generative AI model will not know, will not have this information. So I can pretty much use this model, this ranking model, and it will give me a list of ranking. So I can see that this last one is the one that is the most relevant for the question at hand. We can see even. So accelerated service with H100 deliver the compute power along with 3 terabytes per second and so on. So this is the most relevant one. And if we look further, so we will go beyond re-ranking. Yeah? So this is great, but what else can we do? Well, what if we could create images? And in the world of generative AI, there is a little bit of a divide in the community. There are those who are heavily focused in image generation from the Midjourney community, working with DALL-E and so on, and those who primarily work with text. And as a result, there is not that much of an overlap between these communities. But NVIDIA NIM offers the possibility that those who have never had exposure to, for example, working with image generation, they can do it very easily. So for example, here I have this implementation that is for Scalability AI. Yeah, and I have 2 different models. One is the Stable Diffusion XL, and the one is the SDXL Turbo. So if I go here back to our NVIDIA NIM portal page, so here should be here Vision, or visual design, yes, visual design. Here in Stable Diffusion Excel, there is this one, and there is also this other one here that is the turbo one, that is a smaller one. And you can even see it in the results of this output. For example, look at this output. The dragon that is here displayed, it is visually as a dragon, but it doesn't offer the same level of detail as the example such as this one here, right? So the resolution and just the quality is of photorealistic. So can we do something similar for that? Well, let's try in our implementation. And so we're using these two models, the Turbo and the Excel. And here again, we see that the endpoints, they might be similar, but they have differences. Yeah. So for example, let's go here to the UI to make it more clear. So we see how this prompt, this payload, allow us to have a positive prompt and a negative one, right? So we can say, for example, which words we should exclude or they should be not considered for the prompt generation. We can put it here. And which one should we consider here? But if I go to the turbo one, we'll see that this is much simpler. There is no negative prompt. The parameters are a bit different and so on. So it's again, going back to my point earlier where I was saying how this touted OpenAI compatibility doesn't apply to all models available, just only to some of them. Well, similar thing here with the topic of the format for the payload between this turbo model and the Excel one, that it differs. So whenever we're working with NIM, we also have to be paying attention on what the model requires and a little bit of like fiddling with the system. For some of these models, I spend quite some time just making sure that it works because I will not be able to reproduce the code that I have here available, but it will work, for example, if I will use here, let's say, the user interface. If I will here type, let's say, the prompt, it will work perfectly fine. But if I will try to do this on my notebook in Python, it will not work. And so it's important here to be testing it. But let's go and see what happens, right? So here, in this case, what I want to achieve is I want to generate a logo for the AI product engineer. And my logo is pretty much, if we describe it, is an anthropomorphic dog. He's wearing a cape. It looks a little bit like a mage. It has this retro feeling from the 90s, like flat, and a little bit like these cartoons also from 2 decades ago. So here, I will try to run it. Also, another learning I had running these models is that these models have limitations in how your prompt should look like. So you should be careful here with anything that's related to trademarks or famous names and so on. That will not let you generate. Whereas, for example, OpenAI is more lenient, both through ChatGPT as well as through Bing, to generate images that can be understood as related to some brands or famous names and so on. Here in the NIM implementation, it is very, very strict. So if your prompt is not working, one reason might be that the implementation, the model is rejecting it because of some trademark issue. There is some banned words, forbidden words, and so on. Another difference compared to, for example, the type of images that you can generate using ChatGPT or also using Bing, that is as well using DALL-E in the background, it is that here these models have a shorter prompt input length, meaning if I am very descriptive, in my case, I was saying it should be like a logo, it should be simple to draw, and it should be memorable, etc. It will not accept my prompt, it will be too long. So I had to shorten it. So this means that if you were thinking, hey, I will now replace completely, I don't know, DALL-E, or I will not be using any more Bing, well, not so fast. Maybe for your use case, it might not fit what these models currently offer. Let's see how it is, right? So let's execute this prompt for the Stable Diffusion Excel. So now we have this, and in theory, we should have here in the output a result. Let's see this download the result. Let me open it here on this side of my window. So it should be it generated this result here. So I wanted a image of a dog that it should be anthropomorph, it should be like retro style, and it should be like a flat design. And this is what I generated. We can see how this Excel model has a very high resolution. And this is not exactly like the logo that we have here, but somehow it looks that it could be, right? So would you say it's a mage? To me, it looks more like a medieval somehow dog, right? But yeah, let's see how it will be with the Excel Turbo in this case. And so here, let me download. This is the result that we get now. And we can compare them, right? We can see already the difference between each of them. Right side, we have the Excel model. Left side, we have the Turbo model. Turbo model, smaller size, smaller resolution, but also the level of detail, right? So you can see how I generated this doc is much more basic than the level that we got with this one here, that it has a much higher resolution, but also like how it looks, right? It's much more recognizable. And all of this, I just did it with pretty much calling the model. That the only thing I'm doing is I'm just establishing the parameters. I'm just pretty much like wrapping this API endpoint. And what I do after that is that I have to get the JSON object. And from the JSON object, I have to create an image, right? So here, this is, now I understand why this is happening. But let us here like try again, right? So here, what happened so far is that the image that I showed were from previous runs. But let us see what happens when I run this from zero. Yeah, so I execute this for first the Excel model, and now I execute for the Turbo one. Right now, I only have JSON objects, dictionaries, that have the image, but I need somehow to convert this JSON object into an actual image, right? So that's why here I need to use a base64 and here pillow as library for the image and so on, where I will pretty much take this base64 encoded image from the response API, from the API response, and I will convert them into a actual image, right? So let's do that. Let's see now. We see these ones here. Those that end with 2 are those for this run. Those that do not have a 2 were from a previous run that I had. And let's see, we can compare them in the final results, right? So we can see that the result is the same. This is because I was using a seed and the parameter were the same. And so no difference whatsoever. And this is the same in this case, right? So here we have our dog that is with a lower level of detail compared to this high level of detail dog. Fantastic. I cannot describe how easy it is to generate these images and how much fun it represents. But what if we would like now to use models to describe what is in an image? Well, here also again, NIM offers 2 at the moment, LAVA and NEVA. Both of them are state-of-the-art. Both of them are really very, very powerful. And we'll see now that also they give different results. So here, similarly, in our implementation is notebook, I just call this endpoint. Yeah, so like the in this case, so it will be for the base URL for these image text models. And I have to pretty much in my call here define the name of the models, right? Here will be LAVA and here will be NEVA. So let us do that. What I will do is now the image that I generated with my anthropomorphic dog image, I want that both LAVA and NEVA describe them, that tell me what is inside. So here I execute, and if I now pass the result to the LAVA model, we see here the LAVA result. The image features an illustration of a character that appears to be stylized of Scrooge McDuck, a well-known character from Disney comics. The character is depicted with a prominent nose, a large top hat, and a green coat with red belt. It's interesting that they made the reference of a Disney character. That was not really my intention, but what will happen in the case of here NEVA? We see that the output says the image features a cute hand-drawn cartoon character, which appears to be a dog or similar bird dressed in a green outfit. Well, let's go back to the image to see what is that described. And indeed, it is this dog, it is the green outfit. We can debate if this is Scrooge McDuck or not. To me, it doesn't really look like Scrooge McDuck, but we see how these models were quite detailed in their description. Another exciting thing is how we can create from a single image video using stable video diffusion. And so for example, if I go here to the demo that they offer in visual design and stable video diffusion, we see that they provide a single car image and the output is somehow like the car, so here driving through the desert. And so what happens in my case, if I upload the image of the dog that one of the models generated for me, that the stable diffusion itself generated for me. And here was also like quite challenging to make it work because there are some limitations with this model in terms of you have to first the image process it, you have to compress it, reduce the resolution, reduce the size and so on, in order for it to be available, to be ready to be used for this model. If you just try to upload the image CDs, even though these images that it generates stable diffusion, they're rather small. This one is 100 kilobytes, so it's not that much, it's a tiny image. Still, it was rejecting all the time. I could not understand it because if I go here and then I upload, for example, let's try uploading. Yeah, so if I try to upload this one here, it will work somehow out of the box. Yes, but if I will execute the Python code that it has here for this doc image, it will never. Yeah, so let's see what happens now. And let's see what will happen with when we compare with the video that we prepared through our notebook implementation. Well, it's a bit slow at the moment. I must say, I don't think with our implementation was slow. Yes, now it's generated, but what is it doing? Well, it is somehow like converting into something, transforming. It is a funny thing. In our case, so what will happen now is what I was describing. We take the image, we reduce the size, compress it and so on, and we'll convert it into video. And so here, we take our base image. We'll get, as it was the case with the previous text to image, we get the JSON object and we need to convert it into some, in this case, a video. Before was a JPEG, now will be an MP4 file. This takes a bit longer because, well, it's supposed to be a video, so it will be a larger object. But now here is there. Let's call it just like output. So here my video, output my video 6, so we can compare. And so I execute it. And it should be here now. So it's here. Let's download it and see what happens. So open here and we see that is different than the one that I saw in the in the interface, but also I have created a previous one that I liked even better. So let me see if I can find it. Well, there is this one I generated, but there's also this one that I think was the best one, where it opens Escape. And all this is done pretty much with just a few lines of code. So this is something that is also very different to everything else that is out there pretty much, because I am not familiar with any other offer that let me run this, for example, locally if I have the necessary hardware, or in the cloud, be, for example, a external cloud, or what NVIDIA is offering through its platform of NVIDIA NIM APIs. And not only that, but it also has this wide array of different models available to be used out of the box. And I had to write just this very straightforward code that I'm making available for everyone. But you can see how we pretty much implemented almost everything that is available here. There are many other things that NVIDIA offers. For example, there is this one that is automatic speech recognition. However, this one doesn't have, at least here, a API implementation available. So it only has the UI. It's possible that you can apply to self-host, and this happens with quite some of these models, because this is already still too early. They limit who gets access to what, and also not everything is yet fully available to be queried via Python or Shell to the cloud API that NVIDIA has to offer. Nevertheless, they have also dedicated models for industries. So, for example, in the case of here, like gaming, they have an easy way to have this stream audio to facial blend sheet for real-time listening. So here, let us see, for example, what is meant by that. So here there is an audio sample, and there is an avatar. And so if I click here and run, we can see how on one side it has the avatar, and also we could see the different emotions that it has, right? We also have for industry, for example, there is a weather forecasting. There is also, for example, this one that was quite exciting with object recognition. Let me see if I can find it. Very practical in many commercial use cases. It should be this one, retail object detection. Yeah, so in this one, the original video, the sort of video they provide, is like a cashier, a restaurant cashier, right? So where I'm passing objects, and in the model that I have, it does the bounded boxes, and also describes the retail objects to enable any type of like cashier. So this is pretty much a quick introduction to NVIDIA NIM. To recap, what is NVIDIA NIM? NVIDIA NIM is a platform that provides multiple models already packaged in a very easy to deploy manner, and it can be deployed in the NVIDIA cloud, in your own local machine, in your private cloud, in AWS, wherever it is that you're running. Pretty much you can use, so here, the NVIDIA NIM models. They are highly optimized for this NVIDIA NIM architecture, and they are very easy to run. We were seeing now in the notebook how simple everything was, nothing out of the ordinary. So if you're curious how to use it, just go to build.nvidia.com. You can create an account, you can apply for credits, and start playing with it. I found it fascinating, and I think that this will enable many AI product engineers who want to start building applications, but they think that they need to know more on how to do this, or AI product engineers who, until now, they were using, for example, Ollama, and they find Ollama limiting, be in terms of scalability, be in terms of choice of models, be in terms of like the type of use cases. They want to move to the next level. So really see as or LAMA the stepping stone, and then from there, pretty much something as NIM is a very attractive proposition. What do you think? Have you heard about NIM? Have you played with NIM? Do you like it? There are things that you didn't like? Tell me your thoughts, your comments. I'm very curious to hear what it is about what people are saying about NIM. To me, it was something that I had heard, I had seen the press release and so on, but it was only until I played with it that I understood, wow, it offers a lot of things. It's still very early days, so do not think that it's perfect. As I was mentioning, the API is not consistent. The examples here, they do not always work out of the box. And also, it does not match to what you could get by just using other type of APIs or services. So for example, if you really rely on super high quality images, then the models that are here provided might not be the best ones for you. You might be better continue using Midjourney or DALL-E and so on. So you have to evaluate what makes sense to your use case. But nevertheless, NIM really opens the door for the 30 million plus of developers who are not AI experts, but who like to build things with AI. Well, leave the comments, leave what you think, like, share, subscribe, and as usual, this is AI Product Engineer. We are the platform building the AI products of the future. And tune in for another in-depth review of another exciting AI product next week.